Alright, today we're going to look at the abstraction of flat recursion. It sounds like an exciting topic, doesn't it? Alright, let's look. What is flat recursion? And you should know this by now since we've done it quite a lot. So it's like this function here is a flat recursion function. It just takes a list and it sums everything in the list together. So this should be like 1 plus 2 plus 3 plus 4, which would equal 10. Or there's add one list. That's 1, 2, 3, 4. Takes a list, a flat list. Flat lists don't have any other lists within them. Or if they do have lists, you don't do anything inside of the other lists. And this just adds 1 to every element, so it would return a list like 2, 3, 4, 5. Okay, or there's like product, which would do multiply all those together, which would be, what's that? That would be 6. Alright, so let's what we want to do is make a program, a function called flat recur, which takes like some arguments. We don't know how many yet, and it will return a function like sum or like product or like add one list, because there's a lot of things in common between all these functions here, so we should be able to make it so it's a bit easier to make these. So let's define a couple of these ones and take a look at what's common between them. Alright, but first of all, let me show you a little trick. So remember, with factorial, let me comment all these so that we can keep them there, but it won't mess up the compiler. Alright, fact. Remember the factorial function, that's just like n times n minus 1, so like 5 times 4 times 3 times 2 times 1, etc. Alright, let me just paste this in because you already know this function. Alright, so you can define fact like that, or you can define it like this. The above way is the normal way to do, of course. Let rec helper lambda n, well, let me space these out a bit. Okay, helper lambda n, and then just paste that in there. Oops. And then instead of calling fact, you call helper. Oops. Got to write the name up here, define fact. Alright, so this is the same thing. Fact. Let me hold on here. Alright, so this fact is the exact same as this fact here. Oops, it's not quite the same. Alright, I mean, it will do the same thing, but you see this one's calling itself here instead of calling itself up there. And the advantage of this, having it in the letrec, is that we can name this thing up here whatever we want, and it doesn't matter because we're just calling helper instead of the name of the actual function. And so that's what we're going to have to do when we return a function here, because we're going to want to return a recursive function. So it's going to need to be able to call itself, but we don't know what the name of it's going to be. Alright, so let me just delete those things. Let's define some of these functions. So let's define sum first. So define sum. Oops. Define sum. Let rec. No, not let rect. Let rec. Alright. Helper lambda ls, because that's what they all take, right? I mean, they all return different things. This one returns an integer, that one returns a list, and that one returns an integer. But they all take just one list as an argument. Alright, so define sum let's see here. If null ls, then 0. Otherwise, add the car of ls onto the helper of the could of ls. Alright, got that one done. Let's define product. Find product, let rec helper lambda ls. If null ls, then what we want to return 1 instead of 0, and then multiply the car of ls times the helper of the coulda of ls. Oh, I forgot to say, so we defined helper, but we never actually called it or returned it. Okay, so helper is a function within here. Right, so you see product is not actually taking what is product here. Product is the output of this let-rec statement. And this let-rec statement is outputting nothing. At least this let-rec statement is not outputting anything. So we've got to have it output something. So it has to output a function. We could have it output a function like lambda ls helper ls, ls, like that. Then it returns a function that just calls helper right away. But this is pretty redundant because helper is already a function that just takes ls as an argument, so we can just return helper itself. Alright, so we just return helper, and then so sum is defined as helper, which is this here. It's a bit tricky, but it does work out. Alright, so helper there. Let me just run these to show you that. Well, to make sure it works myself, I don't know for sure. Alright, sum 1, 2, 3, 4 should be 10. Product 1, 2, 3 should be 6. Alright, that's working fine. Alright, now let's hide those interactions. Okay, then let's define one more thing here. Define, let's see. We'll define well, that's it for now. Let's just take a look at what's in common between these two. Okay, so the let-rec's in common. Let's just put it all in capitals if it's in common. Let-rec helpers in common. The lambda ls is in common. Ls, if null ls, that's in common. Alright, this 1 here, that's different. That one's a 0, that one's a 1. And then the car of ls in the times is in common. So let's put that in caps. And the rest of this is in common as well. Alright, so all that is in common between these two. So what is not in common? It's what gets returned here if it's a 1 or a 0 as the base case. When the list gets down to nothing left, then what do you return? That is not in common. And then this function here, this multiplication or addition, and so from there it seems like all we need are those two, just those two operations. And in the next video, we're out of time on this one, we'll look to see if that's right.